All right, let's get to this, guys. Homework number 4, write a function that represents each population as a function of time. So they basically just want the function, all right? They don't want you to do it for any amount of time, at least for this part. Okay, so this is homework, chapter 8, homework number 4. Now, once already done for you, if you kind of take a look, you can kind of figure out where all the stuff needs to go. Like population needs to go is right here, so that's a p sub 0. The 1 is always a 1, right? The rate is going to be that 1.4%. You need to change that to decimal, so move that 1.4%, 2 times 4, so you get 0.014, and then you need to erase the O decimal, so it'll be 0.014. Okay, and that's what they have here, and then to the t power. And then it looks like they finish it off by just combining the 1 plus 0.014. They just combined it together like that. Okay, so we're going to go ahead and try to follow their lead. So we're going to start with, so P of T equals, so our original amount, Youngstown has a population of 12,000, so 12,000, and it's going to be parentheses 1 plus the rate. The rate is going to be 1.2, so we convert that to a decimal, so I'll only do this one time. 1.2%. If you convert it to a decimal, meaning move it 2 places over, your decimal is now sitting here, so you got to fill in the 0. So that's a 0 right here, and that's a 0 in front of it. So now you converted the decimal to a percent, and now you can erase the O decimal, and now you have 0.012. So that's what we're going to write down. So it'll be 1 plus 0.012. Once you get the hang of it, it actually won't be that hard. Okay, and that's your answer, but you can go one more step, and you can combine the 1 and then the 0.012. And that's what I'm going to do right now. So we're going to say P of T is equal to 12,000, okay, times, and I'm going to try to write it like them. So I'm going to go times 1.012 to the T power, okay. Personally, I don't like it like that. Personally, I like it with a parentheses instead of a times, because the parentheses allows it to be separated just a little nicer, just a little easier on the eyes. Okay, so I like it like this better. Okay, but you can do it however you want. Okay, number 3. Okay, we've got Greenville has a population of 8,000. Its population is decreasing at a rate of 1.75.
Yeah, do you want me to come point her out?
So PT equals 8,000, and then 1 plus, well, this is actually decreasing, so we're going to go 1 minus, right? Or you can do it ahead of time if you want. You can go 100% minus 1.75, but we can also do 1 minus the percent. So 1.75, that converts to 0.0175. So we can also do 1 minus 0.0175, and to the t power. Okay, and if we use a calculator for that, so I'm going to use it right here. So if I have a calculator on the side, guys. So I have 1 minus 0.0175. That's going to give me 0.9825. So my final equation, 8,000 parentheses 0.9825. And then this is to the t power. Okay. Number 4, North Park has a population of 14,000. Okay, so that means that I have P of T equals 14,000. And then it's going to be 1, and it's decreasing as well, so it'll be 1 minus, and 3%, 3.1% is going to be 0.031. So it'll be 1 minus 0.031, and to the t power. So we're going to have 14,000. And then what does 1 minus 0.031 make? Well, use your calculator, and you will get 0.969. So you will get 0.969, and that's to the t power. 5. Westlake has a population of 9,500. This population is increasing at a rate of 2.8. So again, 2.8, change it to a decimal, 0.028, and that's what we're going to use here. Okay, now it's increasing, so we don't have to do the subtraction. Remember, it's only for if it's decreasing or we're losing people. So we're going to go P of T equals 9,500 parentheses, okay, 1 plus 0.028. Just like how the other ones that we're doing, except we're adding because it's increasing. Right? And then we're going to go ahead and combine that. So 9,500, and then that's going to combine to make 1.028. And since this is bigger than 1, this population is increasing. Okay, number 6, Springfield has a population of 11,500. So we're going to start that with 11,500. And that's going to be 1. And then this is decreasing. So we're going to go minus and 1.25%. Right, 1.25%. We're going to change that to a decimal, which is going to be 0.0125. So it's be 1 minus 0.0125. And to the t power. Okay. So that you're going to have to use a calculator, 11,500. And then you're going to use a calculator to figure out what 1 minus 0.0125 is. So that's going to be 0.9875 to the t power. Okay, so that's the first 6. You need to pause at any time. Go ahead and pause it. Okay, back page. We're gonna go ahead and see what it's asking. Right. So it says Teresa has a savings account. Function that models her account. A of t for every year t is this right here. And they're just asking what does 500 represent. So I would say 500 represents and if you think back to the equation, this one right here, the one that they give you at the beginning right here. Okay, this is the initial amount or the principal in a sense. Okay, so 500 represents the amount that Teresa first put in the bank. What does the number 1.03 represent in this situation? 1.03 represents that it's a increase. So she's making money or she's earning interest, right? The 1 represents 100% of her 500, which is 500. Right? So it keeps her money the same. And then the 0.03, that's her percent. And 0.03, so 1.03 actually means 1 plus 0.03. So this number needs to be there for the 100%, but this number is the interest rate. It's a percent. So 0.03, if you move this 2 decimal places back, you will get your percent. So if you move 2 decimal places back, you will get your percent. So it's actually 3%. Okay. So what is the number 1.03 represent? 1.03 represents the 100% plus the 3% interest. Okay, same thing. Pablo is using function below to model the value of his car for every year t he owns it. Okay, so same kind of idea. What does the number 21,300 represent? 21,300 represents the initial sorry, represents the initial value of Pablo's car. What does the number 0.08 represent in the situation? Okay, 0.0, sorry, 0.80 represents the depreciation value of Pablo's car. Okay, um, 0.8 is actually, right, 0.80 is actually 1 minus. So if you have 80%, right, how much did you lose from your original value? Well, you start with 100%, so you lose 20%. So 0.80 is actually 1 minus the 20%, or 0.20. So the depreciation value is 20%. Right? So basically, when you buy a new car, it's not going to be worth the same amount. Every year you lose some money from it if you want to sell it. So what 0.8 represents the depreciation, not value, depreciation um, coefficient, right? Or the depreciation percentage of Pablo's car. Okay? And Pablo actually lost 20%. So, okay, I think that's pretty much it. All right, I'll see you guys tomorrow.